right, so hello everyone. I am going to go over the review for the benchmark 2. This is Form D, the one that I passed out in class yesterday. I'm going to go as quick as I can, so if you feel like you missed something or you need to hear it again, obviously rewind and re-listen. Okay, you're going to want to have a graphing calculator handy too to help you with some of these problems. So yeah, I also won't be showing all of the work, but I'll be trying to kind of talk you through most of it here. Okay, so yeah, here we go. All right, number 1. All right, the graph of f of x equals 3 to the x, and its image, h of x, are shown below. So here we have f of x, a function, and then its image, h of x. And when we say image, that means it's a transformation of something. So in other words, h of x is a transformation of f of x. If you look here, right, there's f of x, there's h of x. And we can see here that it looks like h of x is kind of shifted right and up some from f. You can see, for example, that f has its vertical asymptote here at 0, or sorry, horizontal asymptote at 0. H of x has its horizontal asymptote at 1. So clearly we've shifted up 1, right? But then it's also how much over did we shift? Well, if by shifting up 1 here, right, our y-intercept would now be here at 2, and then you can count, well, 1, 2, 3, 4. So we've shifted up 1 and right 4. Okay, looking down here at our options then, okay, shifting up 1, that's where you want to look on the outside here, and you can see that both we have a +1 and a +1 right there, so it's going to be either B or C, or second or third answer choice there. For the right 4, you want to be careful here. It's actually going to be the x minus 4 as our answer, because the number in with the x, you do the opposite of what you'd expect. So a -4 actually shifts right 4, whereas this +4 would actually shift to the left 4, which is not what we want. Okay, so that's our answer. All right, number 2. Select the function that corresponds to the graph that's shown. Okay, it's not really a question, but anyway. You can graph each one of these in your graphing calculator and then just match to the quadratic here. Okay. Another option is to check out what the axis of symmetry is for each one of these. Remember, the axis of symmetry is negative b over 2a. Okay. And that's one way you can figure it out too. So for example, here, if you plug in -4, you'll have a +4 on top over 2 times a, which is, well, 2 times 1. So for example, in here, right, this one would be 4 over 2 times 1, which would give us then 2. Remember, that 2, that's an x value. Okay, and well, if you look here, right, there is no axis of symmetry here at 2, right? Very clearly not there. And so that means this is not our answer, right? And you can keep going through all of these here, doing -b over 2a for each one, and eventually you get only this one would have the correct -b over 2a at -2 there, okay? But again, alternatively, you can just graph each one and see which one matches the picture there. Okay, number 3. Julie wants to use the discriminant. Okay, now you have to remember here the discriminant, okay? Discriminant is b squared minus 4 times a times c, okay? If you're afraid you're going to forget that, that is part of the quadratic formula. Remember, the quadratic formula, which you will be given in the review, is, or in the actual benchmark, I mean, is -b plus or minus the square root b squared minus 4 times a times c all over 2a. So you can see there's your discriminant, right? It's just what's underneath the square root there. Okay? So then it's a matter of using the discriminant here to determine which one of these solutions you're going to get. Okay? So for the discriminant, right, you'll just plug in, so it's going to be, well, let's see here, -1 squared minus 4 times -2 times 6. So we'll get 1 minus, and then let's see here, -2 times 4 is -8, times 6 will be -48, so it's going to be minus a -48, which is going to just a +49. Okay, now remember, since 49 is greater than 0, that means 2 real solutions. Okay, if your discriminant is greater than 0, that means you have 2 real solutions. If your discriminant is equal to 0, one real solution. And if your discriminant is less than 0, no real solutions. Okay, so you'll see here, right, that our answers have 2 places where it says 2 real solutions, but you must also pick the correct one that has the right justification. Because the discriminant is greater than 0, that's how we know we have 2 real solutions, so you want to pick that one. Okay, this, correct answer, incorrect justification. Okay, so that's why that one's no good. All right, number 4. All right, this is our classic border problem here. Yi-Ting, I guess, has a 5 feet by 7 foot picture, and she wants to center it on her wall. That's an 80 square foot wall. Okay, she wants to have the picture placed in the center of the wall, so the border of the picture must be a uniform width all around the picture. Okay, so uniform width of x, so I put those all in there, which makes then this distance right here 5 plus 2x, right? 5 for this little distance plus the x here plus the x there, 5 plus 2x. 7 feet is the distance of the picture plus the x border makes 7 plus 2x. So for an expression means no equal sign, right? Expression to model the total area of the picture, including the border. So 5 plus 2x for this side times 7 plus 2x. Notice you don't have to multiply it out. It's just an expression. It doesn't say put it in standard form or anything like that. If you wanted to, you could put it also. You could multiply it out, and that would then that would put it in standard form for you. But you don't need to here. Okay. Next, we're going to then the border x around the picture when the total area is 80 square feet is blank inches. So in other words, we want to figure out here what the border is. So we're going to take that 5 plus 2x and 7 plus 2x, the expression for the area, set it equal to 80, which is the total area, okay? Then you will need to FOIL this out, right? So you'll multiply it out, so 5 times a 7, 5 times a 2x, 2x times a 7, 2x times a 2x. I'm going to go this way because I kind of like made some space there. So 35, 2x and 7 makes 14, but 2x and 5 makes 10, so that's going to be 24x. And then 2x and 2x makes 4x squared equals 80. Subtract 80 from both sides. And I'm going to rearrange the order here, so I'll have 4x squared plus 24x. And then, again, subtracting 80 on both sides here would give me 45. So minus 45 there, because 35 take away 80 is negative 45, and that equals 0. At this point, then, you could try, ooh, I'm off the screen. There we go. Okay, sorry about that. At this point, then, we could try factoring this thing and then set each factor equal to 0 to solve here. Or you could also, use quadratic formula as well, okay? If you use either factoring here or quadratic formula, you will end up with x equals 1.5 as the only, good solution. Now, 1.5 is an option here, but it is the wrong option because remember that x will be in feet here. Our area was in square feet, so this will be in feet as well, okay? Now, it asks for the answer in inches. You have to convert 1.5 feet to inches. So 1 foot is 12 inches, half of a foot is 6 inches, so 12 inches plus 6 inches makes 18 inches, your answer there. Please be careful with that. Don't do all this hard work and then get messed up because it converted from feet to inches there. Okay. Number 5, in 2009, the population of Ridgeville was estimated to be 7,500 people with the annual rate of decrease of about 2.4%. So a percent decrease, that means we're going to use exponential decay here. So we're going to write a function to model population growth of this town over t years. Let t equal 0 represent the year 2009. Okay? So what is our initial amount? 7,500. So there's our a value right there. Okay? And then to figure out what our b value is, remember in this case, since it is an exponential decay, we need to do b equal to 1 minus r. R, remember, is the percent change. Percent change here is 2.4%, or as a decimal, 0.024. Okay? 1 minus 0.024 gives us the 0.976, which is that option, and the 7,500, which is that option right there. Okay, so those are the two you want to pick there. Exponential decay. Okay, if it was exponential growth, you'd be adding the 0.024 to the 1, and it would give you that. Okay? All right, and there's the function. All right, moving on. Okay. Number 6 here, okay, part A says factor each of the quadratic expressions, select the appropriate factors for each expression. Okay, so in this situation, right, there's some factoring you can do. There's a GCF here, for example, of negative 3. So you take a negative 3 out, you're left with x squared minus 4. Now, x squared minus 4, remember that's the same thing as saying x squared plus 0x minus 4. That is a factorable quadratic equation there, right? You need two numbers that multiply to negative 4 but add to make 0. Well, that's going to be positive 2 and negative 2. And so it factors to x plus 2 and x minus 2. And so there are your 3 factors there. Okay, then for this one, okay, right, it's not a difference of squares, but we can factor it using that product sum method. 2 times negative 3 gives us negative 6. We then need two numbers that multiply to make negative 6, but add to make 5, and that would be negative 1 and 6. Okay, so we will factor by grouping here. We're going to break that 5x up into negative 1 and 6, and then group the first two, group the second two, factor out from each group there. So you have a 2x minus 1 left over. Factor those out. You'll have 2x minus 1 times x plus 3. And so you'll get the 2x minus 1, and then there's your x plus 3 right there. Okay. Notice there will be selections down here that you do not end up using. Okay. So they give you more options than than what you need there. So be careful with what you select. Now part B, it says to solve the equations. Okay, and select the correct zeros for the appropriate quadratic equation. Notice here that this is the same as this, right? So you can solve this by setting equal to 0 here, and then just setting each of our factors equal to 0, right? We already have it factored from the previous problem. So set each factor equal to 0. X minus 2 equals 0, x plus 2 equals 0. And then solve. You get 2 and negative 2. Okay, likewise here, we already have this one from before. So again, use the factored version that we already did, set it equal to 0, and then set each factor equal to 0. 2x plus minus 1 equals 0, x plus 3 equals 0. And then you solve. Okay, an alternative way, if you messed these up and you still want to try and get these right, another way to do this is to graph the left-hand side here, graph negative 3x squared plus 12, and locate the zeros using your graphing calculator, okay, using the 0 command after you press second trace. Same thing here. You could graph this left-hand side and see where it crosses the x-axis, okay, and again, get your answers from that as well. 2 options. All right, number 7. The graph of x squared minus 4 is shown with point R plotted on the graph. The graph f of x is translated to form a new function g of x, okay, such that g of x is equal to f of x minus 1 plus 2. Okay, and remember these transformations from number 1, right? That plus 2 on the outside shifts things up 2, and that minus 1 on the inside shifts things right 1. Okay, so what are the new coordinates of point R prime for this new function g? So here's R on the original function f. We're going to now shift it to see where it's going to end up for g. So we're going to go right 1 and then up 2. And there's our new coordinate right there at 2, negative 1. Okay, 2, negative 1. That's our new point right there. R prime. Okay. Moving on. Number 8, perform the indicated operation, express your answer in standard form. Okay, standard form, very important there, right? Highest to lowest degree. So we're subtracting a polynomial here, so I'm going to change this to add and then make these all opposites. Okay, so now 2x squared, that is like with nothing else, so I have 2x squared. Okay, 8x to the 4th, that is like with my 2x to the 4th there, so I get 10x to the 4th when we add those up. Negative 3x to the 3rd and negative 7x to the 3rd makes negative 10x to the 3rd. And then I finally end up with a positive 4x to the 5th. Now you'll notice here that these are not in the correct order for standard form. I need to rearrange it. Okay, 4x to the 5th is my highest power. Then my next highest is 10x to the 4th. Then my next highest is 10x to the 3rd. Then the next highest is 2x squared, and then we're done. That is in the correct format. Number 9, Ruby is graphing for the following system of inequalities, but she did not have time to shade the regions. Okay, so here's the graph. Here's the inequalities, right? And then which of the following points is a solution to the system of inequalities? Okay, a couple options here. Option 1, you could guess and check each one of these in both inequalities. Only one of these points, okay, will make this inequality true because it says just which of the following. So I think there's only one answer here. So you can guess and check 2 and negative 3. Plug 2 in for x, negative 3 in for y. See if the inequality is true. Then plug 2 in for x, negative 3 in for y there. See if the inequality is true. If this makes both inequalities true, you got your answer. Alternatively, you could shade here and finish what Ruby started, okay? So let's see what Ruby started here. So we have 1/2 x minus 4, so that is in slope-intercept form. There's negative 4, go up 1, right 2. This is my line right here, the solid line. It's a less than or equal to, so I'm going to shade below it. So we're going to shade this way, okay? But then simultaneously, I need to graph this. Now, this is not in slope-intercept form, but if I subtract 2x from both sides, it will be. So I'll have y is greater than 1 plus negative 2x there, or minus 2x if you like. So that makes my intercept 1. My slope is negative 2, so I'm going to go down to right 1. This is my line. It's a greater than, so I'm going to shade above it. And so you can see here's the region. Here's the region where they intersect. Okay? So which of the following points is the solution to the system of inequalities? Let's check. 2, negative 3. 2, negative 3. Well, 2, negative 3 is on the dotted line and the solid line. So since it's on the dotted line, it can't work, right? 4, negative 2. 4, negative 2 is on the solid line, and that's part of the region there. So that's probably it. Let's check 4, negative 7. 4, negative 7 is on the dotted line, so that's no good. And then 0, negative 4, let's check that one. 0, negative 4, it's on the solid line, but it's not part of that shaded region. So no, it's the 4, negative 2 there. And of course, any point in the shaded region and any point on that solid line will work. Okay, next, number 10. The table shows 4 systems of linear equations. Indicate whether each system of equations has no solution, one solution, or infinitely many solutions. By selecting the correct cell in the table, select only one box per row. Okay, so we'll look here at this one first. Okay, you have a couple options. Option 1 is to use elimination here, for example. It is nicely set up for elimination since they're both in standard form. Okay, remember, elimination is where you want your coefficients, when you add them up, to cancel out. So here I have a 3 and a negative 6. I could easily make this this number a 6 if I multiply here by 2. I multiply here by 2. Okay, if I do that, I'll get 6x plus 16y equals 34. All right? And when I go to add these up, then the 6x and the negative 6x, I'll get 0x. And 16y, negative 16y will be plus 0y. And then 34, negative 34 equals 0. So I'll get 0 equals 0, which is always true, so infinitely many solutions, right? Another option is you could solve each one of these for y, get them in slope-intercept form, graph them. You'll see that you end up with the same line, and that'll be infinitely many as well. You could also use matrices here as well, and then, of course, the error, the error that you get with the matrices, we'll show you that. Okay, here for this one, again, it's standard form, so it's nicely set up for elimination. In this case, I'll look at, for the y, again, to make that cancel out with a 2y there, I'll multiply here by negative 2 on the top and negative 2 there. And so that'll give me negative 2y minus 6x equals negative 20. And now when I add up, the negative 2y and the 2y will cancel. The negative 6 and the 6 will cancel, so I have 0 over there. And negative 20 and 24 will add up to make 4. Okay? Since that is never true, right, then there is no solution here. Again, another alternative is you could solve each one of these for y, graph them, and you would see that they are parallel and they would never intersect. So again, no solution. Okay? Here, goodness, it looks like another elimination would be a good idea here. So again, I'm going to multiply the top one by a positive 2, and that'll give me opposites, and I'll multiply that by 2. And so let's say I'm going to have to write it over here. So I get negative 4x minus 18y equals negative 50, and then negative 4x and negative 4, oops, I'm going to multiply by negative 2 to make it opposite, so positive, positive, positive there. Okay, sorry, I multiply by negative 2 so that I have opposite coefficients there. So 4x and negative 4x now will cancel, okay, making 0x. 18 and negative 9 will make 9y. And then 50 and negative 23 will make 27. And so then I have 9y equals 27, so I'll divide both sides by 9. And so I get y equals 3. Okay, and then to get the x coordinate, I can just plug it back in, but I don't need to. At this point, I know there's only going to be one solution, okay, because there's only one y value, and there'll be one matching x value with that y value there. And then here I can see these lines look parallel. I can convince myself they're parallel if I take a look at their slopes. Like there's a point here, and there's a point here, and I'll just count. So up 1, 2, 3, 4, 5, 6 over 2, and it looks like here up 1, 2, 3, 4, 5, 6 over 1, 2, and it's got the same slope. Same slope, they'll never intersect, so there is no solution. Okay? So again, elimination, these are all set up nicely for elimination, or you could have solved each equation here for y and then graph them to find the point of intersection, and that would also help you figure out that system too. Number 11, a local park wants to install a circular patio. They have purchased 850 square feet of concrete tiles. What is the diameter of the largest circular region they could create with the amount of concrete tiles? Round your answer to the nearest foot. Okay, area, and it's a circular patio, so area equals pi r squared. They have at most 850, okay, square feet, so that'll be for the area. And we're going to solve for r here. So we'll divide both sides by pi. Okay, there's a pi button in your calculator there. So 850 divided by pi. Okay, the pi button is second, and then the caret, you can kind of see it there, right there. Okay, there's the pi button. Okay, I get 270.563. And they'll square root both sides here. And I'm just going to go ahead and just do square root of my answer here to make it a little bit easier. I get 16.4. And it says to round to the nearest tenth of a foot. So r equals 16.4, but that's the radius. We're trying to find the diameter. You have to double the radius, so the diameter is twice the radius. So diameter will be 2 times 16.4, which is going to be 32.8 feet. And that's your final answer there. Be careful. Diameter is what you were looking for, not the radius. Okay? 12. Picture below shows dimensions for 2 new swimming pools that are being planned for your neighborhood. Okay? Okay. Create a polynomial to represent the combined area. That means added together. Area of this pool together. And then simplify the polynomial, write it in standard form, fill in the blanks below. Okay, so how do you find the area of a rectangle? Length times width. How do you find the area of this rectangle? Length times width. And we'll add them two together. Okay, now it says standard form, so we have to simplify this. So I'm going to do x times 10, x times 10, 6 times x, 6 times 10. X times x squared. 6 times x is 6x, 10 times x is 10x, so 6x and 10x, 16x. 6 times 10, 60. Okay, then here, I'm going to do x times the 2x and 1 times the 2x. So x times 2x is 2x squared. 1 times 2x is 2x. Now you see we have like terms here. 2x squared and x squared makes a 3x squared. 16x and 2x makes an 18x. And then we have the plus 60. So 3 goes in here, 18 goes in there, 60 goes in there for our answer. Letter B. The neighborhood also decided to add a patio with an area that can be represented by the expression 2x squared plus x minus 6. Match each description with the letter. Okay, leading coefficient, that's going to be your 2 there. So B is 2. Constant term, that's your negative 6, so that'll be E. Okay, the factored form. So we want to factor this thing, so we'll use product sum here. I'll go down here and do it. Okay, so 2 times negative 6, negative 12. I need two numbers that multiply to make negative 12, but add to make 1. That's going to be 4 and negative 3. Okay, break up that middle term using the 4x and 3x. And then group and factor. So we can take a 2x out of that group. We can take a minus 3 out of that group. And they both have an x plus 2, so we can take out the x plus 2 and the 2x minus 3. This is the factored form, right? So you locate that right here. It's letter D, right? Not with the and. D is the factored form. Okay? Then the zeros, well, we just set this equal to 0 and we solve. So we'll say x plus 2 equals 0. We say 2x minus 3 equals 0. So subtract 2 from both sides, you get x equals negative 2. Add 3 to both sides, you get 2x equals 3. Divide both sides by 2, you get x equals 3 over 2. So 3 halves and negative 2 are our zeros there. That is C. And then the factors, and then these are the factors. A is the factors there. Okay, and so there are your answers. B, E, D, C, A. Okay? All right, next. 13. In 2013, a painting was valued at $4,000. In 2014, the painting was valued at $4,225. Assume the painting's value has been increasing linearly, okay? That means we're adding or subtracting the same amount each time since 2013, and that will continue to increase at this pace, okay? So linearly means a constant rate of change. We're adding the same amount each time. So in this case, what will the painting be worth in 2015? Well, again, in 2013, the painting was valued at $4,000. In 2014, the painting was valued at $4,225. And so then in 2015, well, what did we do? We added 225 to get there, so we'll add another 225 here, and that'll be 4,450. So that is the amount we expect the painting to be worth in 2015, just by adding the 225 each time. Again, that's assuming that this relationship is linear, right? But then we go to part B. Suppose the value of the painting is increasing exponentially. So now we're going to multiply, figure out what we're multiplying by. So write the function for the value of the painting in terms of t, the number of years since 2013, round your model to the nearest hundredth. So we're going to use y equals a times b to the x. Okay, a, our starting amount there, is going to be 4,000. And then b, we got to figure out, well, b to the t, I guess, since we're using t there. Oh, and value of the painting. So I guess I should probably use v of t for value of the painting, and then equals, and again, 4,000 for the starting amount, times b. Okay, what are we multiplying by every time? So to get from 4,000 to 4,225, I'll give this work here. So 4,000 times what? Times x, I'll say, equals 4,225. So we'll divide both sides by 4,000. So x is going to be 4,225 divided by 4,000. And if I do that division by calculator, I get 169 over 160. Okay, so my b value is 169 over 160. Okay, now it says round to the nearest hundredth. So I guess I could make that, or you could say 1.06 when you get that as a decimal, and then to the t. Okay, so there's my model. Okay, using the model found in part B, what will the value of the painting be in 2017? Okay, so 2017, we're going to do V of 2017. Wrong, not 2017, because the time is not the year, okay? It's T is the number of years since 2013. So how far is 2017 from 2013? It's 4 years, so it's going to be V of 4, which is equal to 4,000 times 1.06 to the 4. I'm going to use the rounded one because that's what the direction said was to round. So 4,000, 1.06 to the 4th. And we get about $5,049, and we're going to round to the nearest hundredth, which makes sense. We're talking about cents here. $5,049.91. Okay. Last part, letter D, the value of a similar painting can be modeled by the function that, in terms of time, t, and years since 2013, explain what the value of 1.07 means in the context of the problem. So 1.0, that's our B, 1.07, that's our B value, so that means the value of the painting is growing, right, because our B value is bigger than 1, exponentially okay, the value of the painting is growing exponentially, but we can say even more, okay? The 0.07 part means it's growing exponentially at 7% per year, right? 0.07, remember B is 1 plus R in this case, so 1.07 is equal to 1 plus R, and so subtract 1 from both sides, and you get R is 0.07. Okay, that's our percent. 7% per year. All right. 14. A ball is thrown upward with an initial velocity of 30 feet per second from a height of 7 feet. The height h of the ball at any time t can be modeled by the formula h of t equals negative 16t squared plus v sub 0 of t plus h sub 0, where v sub 0 is the ball's initial velocity, h sub 0 is the ball's initial height. Right, the function represents a scenario. Okay, so negative 16 goes in for t squared. That's right from our formula. V sub 0, what's the initial velocity? Initial velocity, 30 feet per second. H sub 0, what's the initial height? 7 feet. Easy peasy. The maximum height to the nearest foot the ball reaches is blank feet. So options. You could graph this in your graphing calculator and then find the maximum using the maximum command. Okay. Or you could also use negative b over 2a, which will give you the vertex, the t coordinate, or the x coordinate for the vertex there. So we'll have negative 30 over 2 times negative 16, which will be negative 30 over negative 32, which implies 215 over 16. Okay, that's your time in seconds. And then we'll do h of 15 over 16, plugging 15 over 16 in for t to get the height at that time. Okay, remember the vertex, this gives us the x-coordinate for the vertex. The vertex is either going to be the highest or the lowest point of your parabola. Since our parabola is opening downwards with the negative a value, right, then this vertex x-coordinate is going to be the location for the maximum, okay, right? Our ball is kind of going like this, so we're going to find the vertex there. Okay, this is the time when it reaches the maximum. We want to find the height, so we're going to plug 15 sixteenths in for h. So negative 16 times negative 15 sixteenths, no, positive 15 sixteenths. Okay, plus 30 times 15 sixteenths, okay, plus 7. And I get about 21.0625 feet. Okay, and again, alternatively, you could just graph it there, which I think is probably the faster way to do it, but I wanted to show you with the calculations and stuff too. Okay, so I was about to say questions on any of that, but none of you are here to talk to me, so that would be a weird question to ask. Okay, so let's move on to part C. The time to the nearest 100th second when the ball reaches the ground. What will its height be when it reaches the ground? Well, its height's going to be 0, right? So we want to set our height equal to 0, and that will allow us to then find the time at which it hits the ground. So negative 16t squared plus 30t plus 7 equals 0. Here, again, you could try factoring. I don't know if that's going to factor or not. You could use quadratic formula. Okay, so negative b over 2, or so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's another option. Or option 3, you could graph and find the 0. Okay, I already have it graphed right here. I had to adjust my window a little bit. If you press second trace, you can go to the 0 command. Okay, go to the left of your 0, hit enter, go to the right of your 0, hit enter, and then go in towards the guess and hit enter, and there's the time, 2.0848475. Okay, so it says round to the nearest 100th of a second, so it's 2.08 seconds. Right? 15. Lamar runs a series of summer camps across the United States. The profit function P of C for the camps can be determined by the function P of C equals negative 20x squared plus 100x minus 12,000, where C represents the total number of children attending the camps. What is the domain of the function in context of the problem? Okay, so remember, x is here. Oops, these are supposed to be c's. It's P of C, so this should be a C here. This should be a C here. Okay, so for the domain, we're talking about what values for C make sense in the context. Well, C is talking about a number of children. So for example, would a negative number of children make sense here? No. So integers, right, include negative numbers. So we're going to get rid, oh, actually, shoot, I don't want to get rid of that one. We're going to get rid of all integers because that includes negative numbers. Rational numbers also would include like fractions as well. And again, fractions of children does not make sense. Okay. All rational numbers, again, include fractions of children. That doesn't make sense. So the answer is our last one here. All integers greater than or equal to 0. Okay. Integers only include like the counting. Integers that are greater than 0 are like the counting numbers. So like 1, 2, 3, 4, 5, 6, 7. Rational numbers also include fractions. We don't want to include fractions in our answers there. Okay, so that's the last one there, letter D. Okay, 16. Given the equation this, identify the vertex of the function. Okay, so again, you can use your graphing calculator there by graphing it. Okay, by showing the work here, you can just say, I use my graphing calculator to graph it. I found the maximum or the minimum. In this case, it's going to be the minimum because our A value is positive. Or, again, the x-coordinate for the vertex, remember, is negative b over 2a. So we'll put negative 10 over 2 times 4, negative 10 over 8, okay, which is then equal to negative 5 over 2. Okay. And so that's the x-coordinate for my vertex, and now I can plug the x-coordinate in. And then see what the matching y value will be. And I get 4. So negative 5 halves, comma 4. Okay. Part B, factor the function completely. Okay, so now we're going to factor it. We're going to use the, well, let's see here, actually. I can see that there is a GCF here. So I'm going to take out a 2. All this divides by 2. Oops, 2x squared plus 5x plus 2. Now I will use a product sum here. So we'll do 2 times 2, so I get 4. So what numbers multiply to 4 but add to make 5? Well, that's going to be 4 and 1. So this factors to be 2x squared plus 4x plus 1x plus 2. Okay. From this group, I can take out a 2x. I'll be left with an x plus 2. And from this group, I can take out a 1. I'll be left with an x plus 2. Lots of parentheses here. We have the x plus 2 in common, right? So we have 2x plus 2, and then the 2x plus 1 is left over. And then there's our fully factored form there. And then finally, what are the x-intercepts? Well, again, you can use your graphing calculator there, graph it, see where it crosses the x-axis, or you can just set this factored form equal to 0. And so 2 will never equal 0, but x plus 2 could equal 0, and 2x plus 1 could equal 0. And so I subtract 2 from both sides here, I'll get x equals negative 2. Subtract 1, divide both sides by 2, you get x equals negative 1/2 if you solve there. And then finally, we'll graph this thing. Well, I've got the 0 there. I got this other 0, negative 1/2. I also have the vertex at negative 2.5, 4. Oh, wait a minute. I made an error here somewhere. There should be 5/4. Sorry, made an error there. Negative 10/8 simplifies to negative 5/4. Okay, my bad. So let's see, 5/4 be like right there, comma 4. Okay, and then if you want, you can get more points, but I think we've got enough points there, right? Just kind of get the idea. Okay, something like that. There's the graph. Okay. But you can get more points using your table on your function on your graphing calculator. All right, last one. Psych. There's more after this. Never mind. Julie posted a motivational quote on her favorite social network. Many of her friends were inspired by the message and also started sharing it with their friends. Julie started to track the number of shares her original post received each day. Her data is recorded in the chart below. Boom. Choose the most appropriate regression model to fit this data. Now you can look here, right? It's definitely not linear, right? Because we are not going up by the same amount each time. We go up by 2, then up by 5, then up by 14, okay, and then up by 33, so it's growing quickly, okay. It's also not quadratic, so it's got to be definitely exponential here with how fast we're growing, okay. So we're going to then come up with the regression model here. So this is where you go to stat edit, clear out the data in your list 1 and list 2, okay, and we're going to type in 0, 1, 2, 3, 4, 5, and then okay, those right there. Stat calc, since we chose exponential regression, we'll go down to number 0, calculate, and so there we go. And it says to round to the nearest hundredth, so I get y equals 1.03 times 2.79 to the x. Oops, and it wants t and f of t, sorry. So it should be f of t equals 1.03 to the 2.79, or times 2.79 to the t. Okay, so this is really the best answer right there. Okay, letter C, part C, interpret the values in your regression model in context of the problem. So 1.03, okay, is the starting amount. So we'll say the starting amount of shares is about 1, okay, and then the shares grow exponentially. Now, since we're growing exponentially here, this is our b value, so it's 2.79 is equal to 1 plus r there. So subtract 1 from both sides, we get r is 1.79. Okay, which as a percent then is 179%. So the shares grow exponentially by about 179%. Okay, shares grow exponentially by about 179%. So there's for our A, there's for our B. Using the model we found in part B, predict how many shares the quote will have on the 6th day. Okay, so 6 days later, so that's easy. We'll just do f of 6. Now, if you didn't get part C, please don't skip part D. Okay, if you got part B, okay, then skip down to part D if you need to. Okay, don't like just assume if they can't do part C that you can't do part D. Okay, make sure you read all parts of the question to see if what you can get there. So it'll be 1.03 times 2.79 to the 6th, and then we'll type in our calculator. Okay, and I get about 485 point, round nearest whole number, so 486 shares. Okay, you got 485.8, so I rounded that up to the nearest whole number of shares, 486 shares. Okay. Bartholomew is buying plants and soil for his garden. Soil costs $4 per bag. The plants cost $10 each. He cannot spend more than $100. He wants to buy at least 5 plants. Let X represent the number of plants and Y represent the number of bags of soil he can buy. Okay? So soil costs $4 per bag. So for the Y bags of soil, 10x for the cost of the plants, and we want that to be less than or equal to $100. And then he wants to buy at least 5 plants, so that means we want x to be greater than or equal to 5. Okay, so x greater than or equal to 5, that's this part right here. There's the graph. Okay, so we're going to shade this way for that. And then for this one, well, it's got to be obviously this borderline right here. Okay, now I can see I'm going to subtract 10 over. I'm going to divide both sides by 4. So I'm not going to multiply or divide by a negative. So this less than or equal to is going to stay that way. So I'm going to shade below. And there's my region, region D. Okay, using the graph above, select the letter of the solution area that correctly models Bartholomew's plant and soil purchases. So section D will include all the solutions there. That's the overlap. Okay, which pairs, x, y, represent the amount of plants and soil that Bartholomew can purchase? Select all that apply. So let's check. 222. 222, that is not my region, so 6, 4. 6, 4, that is in my answer, so yep. 6, 10. 6, 10, it's on the border of the region, but it's a solid line, so yep, that one works. 3, 12, 3, nope, not going to work. And then 8, 4, 8, and then 4, that is in my region right there. And so yes, so these 3 will work when you check them. Okay? 19, function table is shown below. Fill in the blanks with one of the following phrases. Okay, this function right here can be represented by an arithmetic or geometric sequence. Remember, arithmetic, you are adding every time, adding the same amount each time. Could be adding a negative, of course. And geometric, you are multiplying the same each time. So let's check here. 8 to 14, I have to add 6 to get that. If I add 6 to 14, I get 20. Add 6 again, 26. Add 6. Aha, it's arithmetic. Okay, because it increases by a constant rate. Okay. All right, part B, which equations represent the table above? Select all that apply. Okay. So we're going to do a couple things here, right? First of all, since it's arithmetic, our arithmetic sequence formula is going to be f of n equals f of 1 plus n minus 1 times our common difference of d, right? This is like that formula you saw earlier where it's a sub n equals a sub 1 plus n minus 1 times d. It's very similar. It just uses function notation instead of the terms there. So we'll have f of n there equals, and then f of 1, what's our first term? Well, if you go back up here, it's 8, right? So we're just going to have 8 plus, and then n minus 1 times a common difference of 6. Okay, now if you look here, that's not listed anywhere. But if we distribute the 6, okay, like that, and we combine like terms, we'll get 6n, 8 minus 6 is 2. So 6n plus 2, aha, there's that one. Okay? And then also we can talk about doing a recursive definition here. So you look here, these last 3 are kind of like recursive. Well, kind of. But this one says the first term is 8, right? And then it says here the next term is equal to the previous term plus 6. And that's right? If we take the previous term, we add 6 to it, we'll get the next term. So it's also this one as well. Okay? So it's just those 2. This one is clearly no because it's exponential. This one, we're just taking the number of the term and adding 6 to it. That's not right? If I just check it here, 1 plus 6 is 7, but that gives me 8. So it can't be that one, can't be that one, right? First term it says here is 5. First term it says here is 5, and that's wrong too. The first term is 8. All right, last couple of questions here. Number 20, find the value of c that would need to be added to both sides of the equation to complete the square. Then solve the equation to determine the solutions. Okay, so looking at this here, so remember, to complete the square, right, we're looking to create a perfect square here. We want the x's to multiply together. That gives us x squared, right? These two numbers, right, have to multiply to make that c, but they'll also add to make 10. Now, what two numbers? What two numbers that are the same will add to make 10? Well, it's 5 and 5, right? And so then 5x and 5x make the 10x. So 5 times 5, this c is 25. So it means we're going to add 25 over here and get 28 there. So what is the value of c? 25. What are the solutions to the equation? Well, once we have this, we can then bring it down here, okay, and say x plus 5 times x plus 5 is the same thing as x plus 5 squared, which is equal to 28. We'll square root both sides. You get x plus 5 equals the square root of 28. Okay, then we'll subtract, plus or minus, sorry. Subtract 5 on both sides. You get x equals negative 5 plus or minus the square root of 28. Okay, now, none of these answers show that because we can simplify root 28. 28 you can divide out a perfect square there. Okay, it's root 4 times root 7. So you get negative 5 plus or minus 2 root 7. And so that's going to be this one and this one. I got you in percent already.
Oh, you did?
Mm-hmm.
Okay.
So I'll see you later. Okay. So that is the end there of the video. It's a lot, folks. So please, feel free to rewind, look at what you need to get some more information to help there. Okay. And of course, ask me any questions if you'd like. Have a good one.